Okay, in this question we have two soft iron bar that is being inserted into a solenoid. So when we run a current through the solenoid, the two soft iron bar, they will be magnetized. So to find where is the north pole and where is the south pole, we can use the right hand grid rule. The current goes up, then it goes down from the back, then it comes out from the front again. So the current are going upwards at the front of the solenoid. So using the right hand grid rule, the fingers point in the direction of the current. So you go up, and you find that the thumb is pointing to the left side. Hence, at P, this will be the north pole, and then at S, this will be the south pole. And for R, since this side is the south, the side R should be a north. And looking at the iron rod PQ, since P is already a north, Q must be a south. So the answer should be P is north, Q is south, R is north, S is south. So answer is B. Okay, we have a magnet which has a north pole on the left and a south pole on the right. So when they are being broken at the center, the broken end, it will automatically take the opposite pole of the other end. So if this is a north pole, this will become X will become a south pole, and since this side is a S is a south pole, Y will take up a north pole. So the answer should be C. Okay, in this question we have three metal sphere, and sphere X and Y, they experience a force of attraction. So when there is a force of attraction, there's two possibilities. The first possibility is that one is positively charged and the other one is negatively charged. And the second possibility is that one is charged either positive or negative, and the other one is a neutral object. Okay, so we know that X and Z also experience a force of attraction. So now let's look at X and Y first. X and Y, since they attract, it can be one positive, one negative. Can be one positive, one negative. Can be uncharged, positive. So all four can be the answer at this moment. Okay, now we look at object X and Z. X and Z, they attract, so it can be positive and negative, correct? Positive and positive, they will not attract, they will repel. So option B cannot be correct, and option C, uncharged and negative, okay. Uncharged and positive, okay. So the answer is B. Okay, in this question we have to make use of the formula. Resistance of a wire is equal to the resistivity multiplied by the length divided by the area. Okay, so we know that the resistance is directly proportional to the length and inversely proportional to the area. Okay, so if the cross-sectional area decreases by 4 times, we know that the original resistance R is going to increase by 4 times. So it becomes 4R. So how do we get the final resistance as 2R? We have to divide by 2. So how to divide the resistance by 2? We can halve the length of the wire, and that will give us the factor of divide by 2. So the answer should be A. Okay, to solve this question, let us trace the current flow. Okay, let's imagine that the current is flowing in this direction first. The current will be flowing in this direction across this resistor. Then when it comes here, it will split up into 2, and the current will be going in this direction, this direction, this direction across the resistor. Then they will merge back and go back to the power supply. Okay, now when the current reaches direction, current will come out from this direction, and then when it reaches this junction here, the current will not be able to go down to the bottom branch because of the diode here. So the current will only go through this branch and goes into this resistor in this direction. Then after it will come out through here and it goes into this resistor in this direction and it goes back to the power supply. So from this diagram, right, we can see that only 1 and 2 resistor, they carry current in only one direction. So the answer is B.